inside the parentheses here, there's no simplification I could do. These are all different bases. I see exponents on the A and the B, but the C, I don't see an exponent on there, so I'm just going to put a 1 there for myself. And then this looks like a power to a power law again, because these powers are being raised to another power. So let's go ahead and apply that. So here's the A. The power on A is 2, and it's going to get multiplied with the power that we're raising it to. So 2 times 5 would be 10. Moving on to the B, its power is 3. It's going to get multiplied to the power we're raising it to, which is 5. So 3 times 5 is 15. And then the C, its power is 1, getting multiplied with the 5. That would be C to the 5th power. So that would be it for this example. That was pretty much the power to a power law was dominating here. So. Alright, so let's go ahead and approach this guy. Looks like a beast, but it shouldn't really be that bad. I want to point out for the other examples I did, I think I did it the straightforward way because there was no other way to go around it. There's like a million ways you could do this problem, so I just want to point out that the way I'm doing it is not the only way you could do it. So I'm just doing it the way that I see it would be best for me. Okay, so when first looking at this thing, I probably want to simplify the inside the parentheses down a little bit. So let's open up this huge parenthesis that we're going to need. Cubic power, there's a division bar. So there's a negative exponent here, so I know that this base is sitting in the wrong part of the division bar. It should be sitting on the bottom, but with a positive exponent. So I've taken care of this guy here. Here we have the same base with the A's, division's happening. So when division happens, we know we're going to subtract the exponents starting from the top. So I'm just going to go ahead and write the A just once. And I'm going to subtract the exponent. So 3 minus a negative 5. Careful on the minus, right? It's minus a minus. Okay. So I've taken care of all this portion here. Moving on to the B's. I notice that it's the same base again. So I'm just going to write it once. And division's happening, so I'm going to subtract the exponents starting from the top. So negative 2 minus a 2. And this is all inside the parentheses, right? So that would be my approach to doing this. So let's move this guy on up here. Let's go ahead and simplify the parentheses a little bit. 3 squared would be 9 on the bottom here. These negatives we turn into a positive, right? So 3 plus 5 would be 8. Over here, negative 2 minus a 2 would be a negative 4, right? And this is all still being raised to the 3rd power. Okay, moving on. The 9 is going to stay there. We have a negative exponent here, so this b to the 4th is actually sitting in the wrong part of the division bar. It should be sitting on the bottom, but with a positive exponent. And then all raised to the 3rd power. Okay, so now it just looks like it's the power to a power law happening right now. So I think I could squeeze it in right there, so let's go ahead and do this. So power to a power law, 8 times 3 would be 24, so we get A to the 24 on top. There's a 1 here on the 9, so the power on the 9 is 1 is going to get multiplied to the power raising it to. That would be 9 to the 3rd power. And then 4 times 3, that would be B, 12. So this would be your final answer. 9 cubed, what is that? 81 times 9. So you get 729 b to the 12. So this is how I approached it. You could do it another way to see if you get the same answer. Okay, so this is the last example I'm going to do, and then I'm going to have you guys try some, but I'm still going to work it out for you. So look inside the parentheses. I notice I have a negative exponent, so it's sitting in the wrong side of the fraction bar. If there was a fraction bar, so I could make a fraction bar myself, right? So the y squared is going to stay on top, and the negative 3, it's going to come down, but with a positive exponent, applying the negative power law to that. So then we get something that looks like this. And now it's just purely a power to a power law, because these are different bases, we can't combine them. So 2 times 2 would be 4, so we have y to the 4th power. And then 3 times 2 is 6, so we have x to the 6th power, and this should be your final answer. And then the parentheses are just to make it look pretty. Okay, so I have a set of examples for you guys to go ahead and try, and then just apply all the exponent laws that we learned, and then I'll go over it with you guys. Okay, so the way I would approach this, again, there's many ways to approach these problems, right? So I would always look inside the parentheses to see if I could do anything else further, which I can't in this case. I'm just going to give this guy an exponent. So it looks like it's the power to a power law here. So multiplying these powers, we get a to the 4th. Multiplying these powers, we get b to the 2nd. Keep it safe inside the parentheses if you'd like, it's not necessary. You can't simplify the parentheses here, so it looks like it's a power to a power law again. So multiplying these powers here, we get a to the 6th. Multiplying these powers here, we get b to the 6th. Okay, now it's just a straight chain of multiplication happening. So it looks like it's the first law we learned, which was same product, same base. So I see that I have the same base with the a's here, so I'm just going to write the a just once, and I'm going to add the exponents. So 6 plus 4 is 10. And then with the b, since it's the same base, I'm just going to write it once and add the exponents. 6 plus 2 would be 8. So that's what I got. And let's go ahead and try some more examples. Okay, so here's the second example I have for you to try. Go ahead and mess around with it, and then I'll go over it with you. Okay, so I like to look at inside the parentheses first. So there's no simplification to be done inside the parentheses, but I do notice there's a negative exponent here, so it's sitting on the wrong side of the fraction bar. It's on the bottom, it should actually be on the top. So that's the first thing I'm going to fix first. So we just have the 5 on the bottom now, the 3's on top, the x squared's on top, and I just brought the y to the 4th. The y to the negative 4th on top is a y to the positive 4th, and we still have this 3 out here. So I just brought that up. Okay, now it just looks like it's the power to a power law again. So 3, its power is 1, so we're going to multiply its power to the power that we're raising it to. So 3 times 1 is 3. Moving on to the x, 2 times 3 is 6. Moving on to the y, 3 times 4 is 12. I just applied the power to a power rule to all of those. And then you got to consider the bottom also, right? The power on the 5 is 1. So we're going to multiply those together. That would be 5 to the 3rd power. So we get this. You can't simplify the variables down, so we're just going to go ahead and take care of the numbers. So I'm just going to take this guy up here. So 3 cubed would be 27, and I'm going to stop writing the parenthesis now. You can if you'd like, it's just not necessary anymore. So you get 27 on top, x6, y12. And then 5 to the 3rd power would be 125. So that's what I got. Okay, so here's a third example for you guys to try. So yeah, I just want to find out that's a 0 right there. So go ahead and give that a shot, and then I'll go over it with you right now. I'm assuming you're pausing the videos and trying this, right? So so we have the 0 power coming here, which is the best law we learned. Anything to the 0 power is 1. So this is like it's not even here. It's just a 1, right? So that's the first thing I'll do. 3a over 2 raised to the 4th power, because anything to the 0 power is 1. So it'd just be pointless for me to put a 1 there. 2 times 1 is still 2. Okay, so now it just looks like it's the power to a power law again. That seems to be happening a lot. So I'm just going to give these guys some exponents, right? The 3 has a 1 exponent, the 1 has a 1 exponent, the 8 has a 1 exponent, and the 2 has a 1 exponent. So it just looks like everything's going to have a 4 as a power, because you're just doing 1 times 4 every time, which is just going to be 4, right? So we're going to have 3 to the 4th power, 8 to the 4th power, and 2 to the 4th power. And then simplifying that down, you can't do anything with the variable, but you can simplify the constants and the numbers down. So 3 to the 4th power would be 81, and 2 to the 4th power would be 16. I don't think that should simplify anymore. Okay, so this is the last example I have for you. So go ahead and give it a shot, and then I'll go over it with you. Alright, so I noticed that we have the same base here, and there's a division happening. So I'm just going to write that common base just once, and what we do with the exponents is we subtract them when we have the same base and divisions occurring. Starting from the top though, right? So 2 minus 3. For the A guy, the B, the same thing's happening, right? Division, so we're just going to subtract the top from the bottom. So negative 3 minus a negative 5. And then finally the C doesn't have an exponent, so I'm going to give it an exponent, which is a 1. So then the division's happening again, so that's going to be 1 minus a negative 3. So if we simplify this down, we'll get A to a negative 1. We will get B, two negatives make a positive, so we'll get 5 minus 3 is 2. And then 2 negatives also make a positive again, so 3 plus 1 is 4. This is completely fine, but professors often ask you to write the answer without negative exponents. Notice you have a negative exponent here right now. So it's sitting on the wrong side of the division bar. If there were division bars, it should be sitting on the bottom here with the positive exponent. So that's the last thing we're going to do. We have B squared and C to the 4th on top. And then we're just going to bring that A to the 1st power on the bottom. And that A, that 1 is really not necessary, but just trying to show some emphasis. So thank you guys. This was the law of exponents, and I hope to see you soon.